So our lesson today is going to be on scatterplots and regression. So this is just what it sounds like. They're going to be plots that are scattered. So if you take a look here at the first graph, you see all of these different points. And what you want to do is you want to think of the line of best fit. So the trend here is negative, it's going down. And so this is a linear regression. Our choices up here at the top are exponential, linear, logarithmic, and quadratic. These are parent functions that we've already studied. So let's see if we can follow the trend on this second graph. Okay, it's going up gradually, it's going up, it's going up. This is quadratic. This is a quadratic model. Take a look at the exponential. The exponential, it looks like it's going in a straight line and then it shoots up. That's exponential. So what we're going to do is we're going to plot data. We're going to figure out the model that best describes the data. And we're going to find out the linear regression line or the quadratic regression model so that we can make predictions. So let's take a look here. It says explain why choices A, B, and C are not reasonable for this data. So take a look at our points. The points here are scattered about, and we draw a line through the points. This is called our linear regression line. Well, let's take a look at A. A is y is equal to 3x plus 8. Well, we know y equals mx plus b. B is 8, so the intercept is 8. So if you look at it, 2, 3, 4, 5, 6, 7, 8. This is 8, so that's looking good. So then what's the problem with number 1? Well, the problem with number 1 is this is a positive slope. And our line here, our regression line, is not positive, it's actually going down. So let's take a look at number 2. This is definitely a negative slope, so that's a plus because it's negative. However, the y-intercept is 1, and our y-intercept is 8. So maybe this could be it, the answer. Well, definitely the y-intercept checks out, but let's see about the slope. The slope here is negative 3 over 1. So I'm going to write in, let's go for green. If I start right here and I go down 3, 1, 2, 3, and over 1, I'm here. Down 1, 2, 3, and over 1, I'm right here. 1, 2, 3, and over 1. So definitely this line right here, oops, that didn't look good. That line right there definitely is not the model. So that's why A, B, and C are not reasonable. Well, let's think of what an equation would be that is reasonable. Okay. So I would say that if we're trying to model y equals mx plus b, we can clearly say and see that b is plus 8. Now we need to figure out what this slope is. So if I'm here at b, I go down 1 and over 1, 2, 3, I'm on a line. Down 1 and over 1, 2, 3, I'm on the line. Down 1 and over 1, 2, 3, I'm on the line. So this is negative down 1 over 3x. So our linear regression line is y is equal to negative 1/3 x plus 8. And that's the line for this regression. So how do we take that Algebra 1 problem and bring it over to Algebra 2? So we read the question. The table shows the number of AIDS cases in the United States by the year of the diagnosis. So here's your years of diagnosis. These are going to be our X's, and these are the cases, the outcomes. So this is going to be our Y's. So it's telling us here to find a quadratic model. So we already know if we were to graph this data, it's going to look like a quadratic model. So if I haven't said it already, this particular lesson is going to need a calculator. You're going to need a calculator. So we're going to put this in a calculator. And so the first thing we're going to do is we're going to find the stat button on the calculator. You're going to hit the stat button. And what you're going to do is you're going to see the word edit highlighted. And then you're going to hit enter. When you hit enter, you're going to get a list to come up. It's going to say L1 and L2. You're going to put in the values in L1 from your X's. L1 is going to be your X's. So 1999, 2000, all of these will go in L1. Then what you're going to do is go over to L2 and put in the values, your Y values into L2. When you are done, you're going to go back to your home screen and you're going to click on the word stat again. You're going to click stats. Once you click stats, you're going to see the word edit. You're going to go to the word calc. So once you go over to the word calc, all of your options are going to come up. So your options are going to come up. You have a linear option, quadratic, cubic, quartic, exponential, logarithmic. However, this one says quadratic. So you're going to scroll through your menu until you see quadratic. And depending on which calculator you have, quadratic could be in a different space. The one that's in our slide is button number 5. Okay. So once you hit quadratic and you hit enter to move through the modules, it's going to show you your quadratic equation for the data. Here it is. And they're telling you how to set it up. Y is equal to A x squared plus bx plus c. So they're telling you what to plug in for A. They're telling what you should plug in for B and what you should plug in for C. So then what you want to do is you want to take those values for A, B, and C and write your quadratic model. Okay. So here is the written quadratic model. 345.143 x squared minus negative, what is that, 1,380,896.514x. And then you have your constant here. This is the equation. So your next question is, predict the number of AIDS cases in the year 2006. Well, since we have our model, all we need to do where X is to plug in 2006. So you would write that equation down, and then you would go back and plug in 2006 for your X's, and it'll show you a predicted amount of AIDS cases in the year 2006, 51,923. Next question, how many AIDS cases were diagnosed in 1995? What do you think you would do? You got it. Same model, same equation, but just plug in 1995. All right. Here is our second example. The data at the right shows the cooling temperatures of a freshly brewed cup of coffee after it is poured from the brewing pot into a serving cup. The brewing pot temperature is approximately 180 degrees Fahrenheit. Determine what type of model? Exponential. Regression model equation to represent this data to the thousandths place. So here's time. We're going to put that in L1 in the calculator. Here's temperature. We're going to put it in L2. Once we get our data in, we're going to go over to calc. We're going to go down until we find EXP, which is your exponential regression. We're going to hit enter until we can get the equation, and it says y is equal to a times b raised to the x power. Now below it tells you what a is, and it tells you what b is, and you have to just write it down. So y is approximately 171.462 times 0.988 to the x power, because this is exponential. So we write that in. They wanted the regression model. There it is. The next question, when is the coffee at a temperature of 106 degrees? So when is the coffee at a temperature of 106 degrees? So we got to figure out, are we putting 106 in for X or are we putting 106 in for Y? Look at your data and decide. So 106 goes in right here for your temperature, 106. So we have to figure out what value of X. Well, we know the temperature is 106, so let's just go to the chart and figure out where it's 106. Well, it's between 105.7, which is really close, and 109.1. So that's 38 and 42. So our value should be between 38 and 42. So we play around with some numbers and we plug in 40. So in your calculator, you do 171.462 times 0.988 raised to the 40th power. And you're going to get out 105.79. Now you're thinking, oh, could I get closer? Let's see. Why don't you plug in 39 here and see if you get any closer? And I will tell you before you do it that you won't. The next one says, what is the predicted temperature of the coffee after 1 hour? So this is what I want you to do and show your teacher. This will conclude the notes on scatter plots and linear regression. Most of the problems, all of the problems, you're going to be putting in the calculator in L1 and L2. We just have to, when they ask the questions, be able to figure out, oh, do I plug this in for X or do I plug that in for Y? So that's probably be your only challenge with this section. Alrighty, thank you for listening.